Hello friends, welcome to the course on machine learning. Today we are going to start with a new concept, that is SVM. Now in regression there was a concept like SVR, support vector regression. This topic is quite similar to it. It is SVM, that refers for support vector machine. Now SVR was for regression and support vector machine is for classification. So first we are going to start by getting an understanding of intuition behind the working of SVM, and then we are going to implement it in our code. So let's get started. First of all, let's say we have some data points, as you can see here, these red data points and there are green data points. Now we want to make a classification model which is going to classify these data points as red and these data points and green. So our model is going to create a line which is going to separate them as well effectively. The best fitting line can be like a horizontal line, it can be a vertical line as you can see here, and it can also be a diagonal line. Now there can not only can be one diagonal line, it can be anything like three diagonal lines like this and like that. Let's say there are three models and all the three models split both the red data points and green data points. Now but these model, this best fitting line doesn't affect the data point for training but for the testing. This line is important for the classification because it is going to classify the data point. Suppose let's say we have a data point around like here. So for the first line, this it is going to classify it as a red data point, but the second line, that is the middle one, which is going to classify that red data point as a green. Now it is required to have an optimal line which is going to split and classify all the data points effectively. So in order to do that, we are going to use the margin concept, that is similar to the SVR. So to do that, it is going to fit the model with a line with the maximum margin between the data points, and these data points will be equidistant from each other. Now these and the data point that is going to choose will have a specific property for like it is going to pick a data point from the red data set which have the most traits common with the green data points compared to the others. So for this red data point will have more traits compared similar to the green data points compared to these, and similarly for green data set this data point will have more traits similar to red data points compared to this data compared to the remaining data points. So it's going to pick those data points and going to create a line to fit this in such a way that they will be equidistant from each other and will have the maximum margin between them. And in this manner they are going to create a model line, then they are going to create a line which is going to split and classify both the data points. And that's why these data points will be referred as support vectors. Now the margin and equidistance and the best fitting line will only depend on these support vectors. Even after, if you have only these two data points and suppose like these data points are not available and these data points are also not available, there are only these two data points are available, so the model is not going to change because it depends on only these data points. Now why these data points are referred as support vectors? Because it's just a two dimensional. Suppose there are many variables like 3 4 5 6 7, so in 3D space these data points are referred as vectors, and they work similar to as vectors. So that's why they are referred as support vectors, because they are supporting our classifier here. As you can see here, these data points will be treated as a support vectors. Let's say we'll start with an example. Suppose we want to make a classifier that is going to classify oranges and apples. So let's say there are data points like there and here which are of the apples and normal oranges and like that, but support vector machine doesn't work on them to classify the object, else it works on the exception. As you can see, as you remember, I said before that it depends on the data point with the traits most similar to the another class, that so it will be like it's going to classify on the basis of the apple. As you can see here, this apple looks similar to the oranges, and similarly it will treat the it will also take an orange that looks similar to the apple and things like that. As you can see here, is this green orange? Oranges are usually orange, they are not green, and it's less bumpy compared to that, and it looks similar to the green apple. So it's going to take exceptional data, and then it's going to fit line on the basis of those by taking them as a support vector and creating a line, or I mean splitting on the basis or using a line with the equidistance from those data set and with the maximum margin between them. So that was the basic intuition behind the working of SVM. So let's try to implement it in our code. As you can see here, let's start by importing our required libraries, which is NumPy and Pandas. After importing libraries, let's say we have a dataset social network ads.csv. So let's say we're using this, so the same dataset, let's create a data frame named dataset using pandas library dot read csv function, and then we pass the csv file, I mean our dataset. After that, we used we used dataset iloc method and created our independent variable and dependent variable x and y, and in which we pass colon for all rows and 2,3 for age and salary, and similar to that we use colon for all rows for dependent variable and 4 for our output, which is purchased or not purchased. We use dot values to convert it into array. So after executing this line of code, as you can see here, that's the dataset that we are using: user id, gender, age, salary and purchase. And we created two variables: our independent variable x, age and salary, and our dependent variable y. Now after that, first we are going to split our dataset into training set and testing set. So let's say from Scikit-Learn.model selection, we import our function train test split, and then we are going to use it to split our both the independent variable and dependent variable into training set and testing set. So we are going to pass xtrain, xtest, ytrain, ytest equals to our function train underscore test underscore split, and then there we pass x comma y, our independent variable and dependent variable, and then we specify text size, which is 0.25, that is 25% for testing and 75% for training, and then we specified random state equals to 0. Now after that, we need, as you remember, we need to apply feature scaling on it, because age and salary are not quite comparable. So we are going to use it like from sklearn.preprocessing. We are going to import standard scalar class, and then we going to create a class an object of standard scalar class, that is sc is equal to standard scalar. After that, we are going to apply feature scaling on both xtrain and xtest. So let's say xtrain is equals to sc dot fit underscore transform, which is going to fit the feature scaling first, and then it's going to transform the training set. So we are going to use sc dot fit underscore transform function, and in which we are going to pass xtrain. After that, we are going to apply feature scaling on testing set. So xtest is equals to sc dot transform x underscore test. We only used transform because we already fitted our feature scaling on data. We are going to transform it into using feature scaling. Let's execute the above the line of code. As you can see here, we got xtrain, xtest, ytrain, ytest. Now after that, you can also see that we apply feature scaling on xtrain and xtest. Now we are going to import a support vector classifier, that is our classifier class, models class, already available in sklearn.svm. So we are going to import it using from sklearn.svm import svc. Now after executing that line of code, we are going to create an object of svc. Let's say we create a model named classifier equals to svc, and then we are going to pass kernel is equal to linear and random state equals to 0. Random state is equal to 0 for not using the random data points for more training, and not picking random else. Now here kernel is equal to linear. There are many types of kernel already available for training. As we are going to use linear here, we are going to get an understanding of the kernel or why it's required in the next session in the kernel SVM. So let's put it linear as it is, and then we are going to put random state equals to 0 here. We don't want any random equips of data points for our training. So after executing this line of code, it's going to create a model named classifier, as you can see here. After that, we are going to fit, or I mean train it in on the basis of training data. So we are going to use classify.fit, and then we are going to pass xtrain and ytrain here. Let's try to make prediction using our classifier. So we are going to use ypred equals to classifier dot predict, and in which we are going to pass x underscore test, that is our training set data. After that, as you can see here, that's the prediction that our model made, and extra y test is the prediction actual value. The y test is the actual value, so you can compare these values. They are totally similar. As you can see, our model make prediction 0 0 0 0 0 0. They're also 0 here, and it's 1 on the 7, and 8 9 10 are 0. So it seems that it's making good predictions. So in order to get the accuracy, we are going to compute our confusion matrix. So for that, from Scikit-Learn.matrix, we are going to import confusion matrix first, and then we are going to create an object of confusion matrix, that is cm is equal to confusion matrix, and then we are going to pass both the values, the actual value and the prediction, so y test and y pred. Now after that, this is the cm, that the confusion matrix that we just created, and as you can see here, the above values are actual value, and the value on the left are the prediction made by our model. As you can see, the actual value was 0, and our model makes 0 also for around like value 66, and the actual value was 1, and our model made a prediction of 1 also for a value around like 24. So as you can see here, it makes quite great prediction, and adding the value 66 and 24, it gives 90 out of 100. So the model making prediction and the accuracy of 90%, and that's quite great. So that means our model making quite great prediction. So that's it for our today's session. In the next session, we are going to start by understanding the kernel, what is the use of kernel, why it required, and we are going to understand the concept of kernel SVM. Now that's it for our today's session. Hope you like it. Enjoy. Keep learning.